Our goal will be to do a little bit more of this section, so you can see that besides formulas for cosines and sines, there are also formulas for tangents. I say, what about their friends cotangents? Well, you can always write cotangents as reciprocals of tangents, as well as if you have secant or cosecant, they're reciprocals of sines and cosines. So you could just flip all of them and that'd be good enough. But I don't think you ever encounter this type of exercises unless you select some special topics that get real to dig deeply into all of these textbooks. But it's not standard kind of exercises, and it's just lots of algebraic simplifications involved. So if you have two tangents added and then divided by 1 minus the product of those two tangents, turns out it's going to be nothing else but tangent of a sum of these two angles. And looks like it's standard here. So if you change plus with a minus, then all pluses change with minuses, like plus on the top changes with minus on the second formula, and minus will change with a plus. So it's pretty standard for these kinds of formulas. I can apply it once just to, I guess, see we can deal with tangents as well. As long as formula is provided, then everything is fine and we can just utilize it to plug things in. So let us do exercise like 35. Looks like there is a tangent involved here. So I can try to see what they want from us. They give us that tangent alpha is -4/3. Okay, that's a good start. And then we have also the fact that cosine beta is 1/2. Okay. Cosine beta is 1/2. So how about if I try to find the tangent of alpha plus beta, which is going to be a part, actually they have tangent alpha minus beta. Okay, so you can find tangent of alpha minus beta. That's a part D of this exercise. So first of all, I'm going to write down the formula where I need to plug things in. So it'll be the tangents on the top. Now they be subtracted because we look at the above formula and we change the sign with a opposite. So plus with a minus. And on the bottom, I'm going to be adding the product of two of those tangents, alpha times tangent beta. Okay. So looks like what I need to do is find tangent. And if I have cosine, then how can I get to the tangent? Well, tangent is sine over cosine, right? So if I have a cosine, then I need to have a sine. So if I try to find the sine, then I can, well, guess what? Use my favorite, right? Unit circle as usual. So if cosine is 1/2, then there are two possibilities for our angle. It could be either here or there, right? So it could be either positive, and we know that for 1/2 is at pi/3, right? You can check with the back of the book. Or another possibility is negative pi/3. So there are two points on the unit circle that have same exact coordinate. And it's always the case. It's standard. So if they say that angle beta is in the first quadrant, then I don't care for that one. because it's in the fourth quadrant. And I just take that other one. So when 1/2, its friend will be a square root 3/2. I hope you already remember this. So if that's a sine beta, because angle now we got a beta here. So we got the other result. So if a sine is found, which is square root 3/2, then I get my tangent. That's what I really need here. So it'd be a quotient of these two numbers, just like from definition. It doesn't matter if it's a sine or if it's a, what did I write? Sine or cosine. So it was not or cosine. So to get my tangent, I get to put the fraction sine on the top, which is square root 3/2. Let me use another color so it'd be better visible. Square root 3/2. And then I divide this by 1/2. And we already know that little algebraic simplifying shortcut. So I just take these denominators and cancel both of them. So I multiply and divide by the 2. So all these denominators will go away. And I get the answer, radical 3. So you end up doing this little algebra. And now it's a key moment. We use in the formula, right? So let me write it carefully. We have tangent beta found. So I'm going to be using tangent alpha, -4/3. So what I do is I utilize this new formula. So technically, you have a formula, you don't really care much what you plug it in, you just plug it in. Square root 3 is for the other one, for tangent beta. And then 1 minus their product. So I multiply -4/3. Notice that I better put parentheses, right? By square root 3. So this is the answer that definitely could be simplified. And to simplify, I have to, well, do same thing as I just done before. So I see denominators are 3, so I multiply by 3 my top part, both pieces, and my bottom part, both pieces. And I multiply by 3 to cancel it here and here. So this is gonna look nicer. So let's see what's left. -4 from the first piece. 3 square roots 3 from the second piece. Right? Then 3, 1 times 3 is 3. Now 2 minuses is a plus. 4 radical 3. That's it. We have the answer. So, as usual, we don't really care what formula it is. Once you have those ingredients that you plug into this formula, everything is just nice and perfect, and you just get your answers. And of course, the complex fractions is a good idea to simplify and say, what if I don't? Well, okay, I still give you the credit. But point is, don't start simplifying so it goes wrong. Because I know that sometimes people start doing all kinds of things, like say, for example, just make up example, 4 plus square root 3 divided by 3 square root 3. And they say, okay, I see square root 3 on the top and the bottom, so I'm going to cancel like that. This is wrong. Why? Well, because you forgot about 4. You also need to divide by square root 3, 4. So you're going to have to put square root 3 underneath 4. If you divide by square root 3, you have to divide every single little piece by square root 3. You see? And that's not going to give you any better expression. It's going to actually be something pretty unpleasant looking with this extra denominator, so nobody really needs it. So you can cancel only when it's factored, only when it's multiplied. When it's added, you can't. You have to divide by that every term of your fraction. So don't get a feeling that we're gonna abandon this story because the next section heavily utilizes it. So what I mean is formulas that we saw last time for sine of alpha plus beta, as well as cosine of alpha plus beta. So to recall, it's a sine cosine, sine alpha cosine beta, plus sine cosine, but now it's sine beta cosine alpha. It's lengthy. So what if somebody says, Alex, take same angle, alpha plus alpha. Okay, so everywhere will be only alpha. It'll be sine alpha cosine alpha, right? Plus sine alpha cosine alpha, according to the formula above. So we got two exactly the same terms that we're trying to add. So the sum will be 2 times sine cosine, sine alpha cosine alpha, right? Cosine alpha. But on the left side, it's going to be so-called sine of double angle. And that brings us right into the next section that deals with these so-called double angles. And I just justified first formula for you. Analogously, you can justify the second formula by using cosine alpha plus beta and doing exactly the same thing. You just write out the formula that's going to be what? Cosine cosine. So it's cosine alpha and beta. Subtract sine sine. I memorized this, but you don't have to. You can just look at the, remember, very end page of the textbook and you will see it there. So if instead of alpha, instead of beta, I put alpha, I'm going to have exact same thing. I'm going to have cosine squared, if that both be alphas, minus sine times, oh, that's a sine times sine. Let's see, I got carried away a little. Fix this real quick. So we're going to have cosine, sine, sine. So now all betas will turn into alpha, so it'll be sine squared. You say, oh, that reminds me, sine squared, cosine squared, that's 1 if you add. If you subtract, it's not 1. It's a cosine of double angle to alphas. We just justified that. Now, I think I should do a couple of exercises and then I talk about the next two formulas, because this section has a lot of information. It has also so-called half-angle identities. I will discuss them next time. I don't think it'd be a good idea to touch those right now. So today I just want to talk about these two formulas, and then the others will bring us to actually what you see right now here on the bottom, this so-called half-angle identities. They're pretty straightforward. They are really straightforward, but I think we should get used to this two formulas that I just produced first, and then we're going to move to the, I guess, next step. And again, my goal is to introduce you with these formulas so you know that they exist, you know where to find them if you need. They're not very often appear in the exercises, but sometimes they do. So again, for people that plan to go for the calculus classes, it's important to be aware and be able to use them. So I'm talking about double angle formulas that I just justified for you using the previous section. So it's all pretty straightforward. That's why the previous section is important, because based on it, we got more stuff that I guess is useful. So for now, I'm gonna try to find some of these double angles here. So how about the exercises in the first group? Maybe problem like 11 will be good to start with. So section 7.6, exercise number 11, that says, find sine of double angle, part A. So here we have cosine. So actually, sorry, that's 11. 11 is cosine also. Okay, so they gave us that cosine of angle theta is something like root of 6/3. So it's not a standard angle, but that's absolutely fine. So we can actually utilize the formula. So they say in a part A, give us sine of 2 theta. And for that, I need to have both and sine and cosine, because it's 2 times sine times cosine. So I have cosine, that's great. What's missing is a sine of that angle, and that's the whole point. And Pythagorean theorem right away tells us that sine is a square root from 1 minus square of a cosine of angle. But the question is, what's here, plus or minus, right? Could be positive, could be negative. So quadrant will tell us that. That's why unit circle is always with me. So if cosine is something negative, whatever it is, I don't care. It's just a root of 6/3, wherever it will be. There are two possibilities for the sine. So it could be either above or below, right? So sine is, so corresponds to two angles. So which angles do I take? This one or the one below? And the quadrant will tell me that right away. So once you made a picture, you're pretty much done, because it says that quadrant is here, second, right, between pi/2 and pi. So this is my angle theta. And all I care about is the sine, which is positive. Because it could have been negative if they told me from pi to 3 pi/2, it could be negative. So it's up to them. And of course, the result will change. Instead of positive, it'd be negative, or vice versa. So let us get the result for other piece here. And then we're gonna move to using that new formula. So I'm gonna be producing expression for the sine of theta, which is a positive square root from 1 minus a square of cosine. So it's a minus root of 6 divided by 3 squared. Okay. So here's the square root from 1 minus. Now square root 6 is going to give us just 6. 3 squared is 9. So it looks like I can put 9s. When you say, Alex, don't you want to cancel? No, because 9 is a nice denominator, because inside the square root, I can extract the square root. So standard thing. 1, you turn into 9 of these 9s, and then you will be able to subtract from 9, 9, 6 9s. So you get a square root from 3 of these 9s, and then you get the sine theta with denominator 3 and numerator square root 3. And that's really all I need to be able to plug into the formula above. So 2, now instead of sine, I put root of 3 divided by 3. Instead of cosine, I put negative root of 6/3. So let's multiply. So the result will be -2. Now it's inside the square root. I have 3 times 6, 18. So 18 I can write 9 times 3, right? So I can write this 18. No, 9 times 2. Should be careful. So we have 2 factors of 3 on the bottom, and here everything is multiplied. So you can cancel. If there is a plus or a minus, don't even think of canceling. You will really upset your grader. Well, I'm not gonna just give a failing grade, but some instructors, they do. They get so upset, they say, you upset me, fail. No, they're gonna take off a point, but it's not gonna be a huge thing, but still something that one should know by this level of class, that you can cancel only when it's multiplied. That's important. So it's a little bit time consuming, but not now. The reason is that you can get a part B here done in a pretty straightforward way, because you already know the ingredients. You already know sine and cosine. So if you have both of these guys ready, then it'd be pretty straightforward to do part B, to get cosine of 2 alpha or theta, it doesn't really matter. It'd be cosine squared minus sine squared. So you have cosine, which is a minus root of 6 over 3 squared, subtract sine squared, which is going to be a root of 3 over 3 squared. So right away utilize the formula above, so you get a 6 over 3 squared, 9 minus 3, no square root, right, over 9. 6 minus 3 is going to be 3 of these 9s. And that one you can nicely cancel, get 1/3. So this is your next result. And as you remember before, we were doing this various parts, A, B, C, etc. So there was like find tangent, and then you divide sine by cosine, then you can find all the secants and cosecants. So you just flip these results. But I guess the key part is sine and cosine, and that's the idea. So that's why they already gave up on this. Now, 2 other parts deal with half angles, and that's something I plan to do next time, because it'd be too much of overload in terms of formulas. This section has a lot, just like if you remember before, we had was this arc sines, arc cosines. I was stuck for 3 class meetings with this, and I was a little bit disappointed because some people never actually, I think, paid attention. They just utilized the calculator. I'm not even sure what that brought to various answers of different kinds. And that's why I told my students, to you guys, that you can redo this midterm. I'm fine with that, as long as you learn this eventually. So this will raise your grade for the class by 1 higher. So say you got a B, you will get A. So I think worth it. And just give it a thought that I'm talking about the beginning of chapter 7, section 7.172. I know this is time consuming, but I think it's pretty straightforward there, because I explained how to do this in the midterm review, and it is on that little YouTube channel. I hope you still have access to it, because it's there. So I'm waiting, and if someone didn't turn in homework, and I have people of that type, they still can accept it. So utilize this opportunity, do it, because for the final exam, I'm not going to ask these questions. If you postpone this till the end of semester, you'll have plenty of new stuff to learn. You see that what we're doing now is quite different compared to those arc functions, right? and graphing that was on the midterm. We're gonna do some algebraic type of stuff. And that's why you don't wanna leave that for December to study, because that's different. And that's better be done if you want, of course, to raise your grade up to date higher. You should do it now. Don't wait till December. In December, you will have plenty of other stuff to work on. Okay. So anyways, it's again up to you. If you're satisfied with your grade, that's good. So then just keep doing what you were doing. So anyways, let me do one more here because they're tedious and we just want to, I guess, make sure that you feel comfortable when you see like a double angle or something. So let me do number 47, which is a little bit different. Because I'm sure if you know how to...
Professor, sorry to interrupt. I have a question about the homework.
Yes, I'm waiting.
Can we, like, how do we send it? Like, we email it to you, correct?
Yes, my email account. Just like you said,
And
midterm.
how many can we send, like, pictures of our homework? How many pictures can we send in each email? Like 3, right? Because
Maybe
if not, it won't
2,
load.
yeah, something like that.
Okay,
If you,
perfect.
yeah, you can
Thank
send
you. I
it to your
appreciate
email.
it.
Yes, absolutely.
Thank
That's
you.
good. Very good that you're gonna do it. Good. Yeah, absolutely. Yeah, don't hesitate. Ask questions. I'm sure your question will be beneficial to other students that still wondering if I should send homework or not. People emailing me, Alex, can I still send homework? Yes, send it to me. Don't keep asking me the same thing and never send me this. Send it to me. Send me whatever you have, please. So anyways, the type of exercises we already encountered previously was to establish the identity. So on one hand, let me copy this whole thing, is cosine to the force of theta minus sine to the force of theta. And we have to find out if this is really equal to double angle cosine to thetas. And as usual, this so-called left side looks worse, and that's what we should usually start with working on, always with expression that looks a little bit okay, yeah, you can put this on the drive with a link, and that's fine with me. So that's good idea. Yeah, anyway you submit it. So far I was able to get all of those. Just try not to put anything on Canvas, because I already tried to explain numerously, but people still using Canvas anyways. You say, Alex doesn't like Canvas, I'm gonna use it. So don't do that, because I cannot open very often. I cannot open anything on the Canvas. I have no idea. This Canvas is very odd program. So just instead of sending it to Canvas, send it to me. Simple. So anyways, here's the cosine to the force minus sine to the force. So what do you do when you have x to the force minus y to the force? Well, you factor it, right? You use that difference of two perfect squares. X squared minus y squared multiplied by x squared plus y squared. Because if you FOIL this, you're going to have first term squared, so x squared squared will be force power, and same with second term, minus y force. So now instead of x and y, I have cosine and sine. Okay, so I put cosine squared minus sine squared multiplied by cosine squared plus y squared theta plus sine squared. So I'm working only on the left side right now, and I'm trying to produce this right side. That's my goal. So remember what this is? 1, right? Favorite Pythagorean identity. What's the other one? Cosine squared minus sine squared. It's cosine of double angle. And that's it. This is my answer. So we say this is same as a right side. So from left side we started and we produce the right side. So it's not that bad. So exercises of this type I think are useful. Once you start getting lower in the problems, they start to be more and more sophisticated. We don't really want to get into this because our goal is to learn basics. And if you move to the later part, it'd be a little bit more challenge. So I don't see really much I can ask you for the quiz. So I can do one more instead. I think that'd be fair. And so if you doing it, I will do. I just saw some equations and I want to make sure that you don't forget how to use equations. So if I try, for example, exercise number 69, which is the recommended one, it looks like in this exercise, I will be dealing with the same formula again, cosine of doubling. So what I do is erase the stuff we don't need, and this will be above. I'll just leave this double angle. New formula here. So I'm going to use this. So in that exercise 69, I'm being very selective. I'm trying not to select something very extremely tedious, but if someone is interested, I can always do one. And I think we already tried something like that, right? But again, I think if I concentrate on the worst looking kind of problems, lots of students will get a wrong feeling that I'm trying to make this class as hard as possible. No, I'm trying to make it simple, but I still want to introduce you with some of these topics. So anyways, here's our formula below that I'm going to utilize right now. So it'd be cosine squared theta minus sine squared theta, right? So that's instead of underlined cosine of double angle. And this is really no good because we got a cosine of double angle. It'd be better if I could replace it with, remember, sine squared plus cosine squared is equal to 1. So instead of cosine, I could put 1 minus sine squared. And that's actually one of those formulas. Remember, I told you I would look at next time, but I think it next time came right now. So it's 1 minus sine squared of theta. Again, from the new, maybe I underline it in red. So instead of cosine squared, I put 1 minus sine squared. And there is still another friend of it that patiently waiting. It's a minus sine squared again, and plus whatever is here. With that part, I don't care. I just copy so far. So at the end of the day, I ended up with a new formula here. So instead of writing cosine of 2 theta, cosine, produced 1 minus sine squared. You see? That's another way to write the formula below. And I want to scroll up a little bit and show you that list of formulas I was referring to in the beginning of today's class contains that other representation for the square of function, actually for double angle, for cosine of double angle. That's another. See, it takes a little time to open. So here it is. So this is the next formula. And it's simply produced by combining this Pythagorean identity and writing instead of cosine squared that 1 minus sine squared. So you get 1 minus 2 sine squared. And analogously, you will produce the formula, the last one, number 4, or third representation for the cosine of double angle if you don't want to write it with sine squared, but with a cosine squared. And that's actually a step into the next group of formulas that we'll do next time. So anyways, let's see what's left. So it looks like I got a bunch of signs. There are 2 negatives and 6 positives. So it's actually 4 sine squared of theta. And I can bring, okay, I can still have 1 here and then 4 on the other side. So I can subtract on both sides number 1, but before doing it, I want to clear all this, get some room. Like I say, it'd be nice if you didn't have that 1. Well, it doesn't matter, it's just same thing. So you minus 1 on both sides, and you're gonna get that your 4 sine squared is equal to 3. And now we isolate sine. So we have sine squared is 3/4. And then when I extract the square root, I get that sine is, and that's plus minus, remember, square root 3/2. Oh, that's the favorite angle, right? And to be able to now complete this, to solve this equation, I need to get my favorite unit circle here. So you see the angles, and you probably already recognize something that deals with either 60 or 30 degrees, right? Radical 3/2 is associated with these 2 angles. So when sine is radical 3/2, it could be either positive or could be either negative. Then you have 2 points here when your sine is radical 3/2. Or when it's negative, there'll be 2 more points here and there. And the angle that associated to it is 60 degrees, or people say pi/3. Okay, so looks like it's 2 of these pi/3. Take angle twice over 3. And then there is a 3, 4 pi/3. Right? And 5 pi/3. And since we have a clean angle, straight line here, straight line. Since we have a clean angle theta, we don't really need to bother with this period. You can put period to the first, 2 pi k. Let me write them out. So you can put period 2 pi k with each of them. But I think there is a neat way to describe these two because they're like opposites. So the period will be half rotation. So you can say that theta is either pi/3 plus pi k from the picture, or the other two. I can put them in green. This one and that one. So I can say it's 2 pi/3, right? Plus pi k. Please notice I couldn't write this solution in one expression because I would have also taken these. So if I went plus pi/3k, I would have picked up 2 more, and that's not present. Well, I think that's enough. It's just getting more and more involved. If you'll be able to look at this sometime tomorrow, again, I'll send you a recording as usual. Think it'd be very helpful before the next time. Because as you can see, the material is not getting nicer, right? It's heavily utilizing whatever we did before. And that's the way this class is. So it doesn't have unrelated topics. Everything just gets more and more involved. And that's actually the same thing with calculus classes. So they expect you to remember lots of things, not in your memory, at least to know where to find. You may not remember formula for sine of 2 theta, but at least when you find it, you should be able to use it. That's the idea. So you should be familiar with them. That's the point. Because if you're not familiar, then you have no clue what they're talking about. So you really need to somehow relate it. And that's why you should not wait for a semester. If you have to go for Calc 1, well, sign up for it for this coming spring, because schedule is available, registration is open. So go ahead and sign for it, and don't wait another semester till fall, because these things will be all used, and people forget things. You don't use it, you forget it. And these classes get filled up real quick. But if you're looking for the online, or actually that live, I advise you to look for the other campuses, and maybe in bigger campuses, they might provide it with live option. So it doesn't really matter. You take this class at the West Campus or in Kendall or in North Campus. Those are bigger campuses. They have way more sections of the class. But again, sign up for it today, because you're doing good, you're passing this class, so you can just sign up for it. If my permission is needed, of course, I'll give it to you. Just email, have those counselors email me. But again, it's up to you to find those in a schedule of classes, because it's online, so I'm sure you already know how to use online schedule of classes. So I think this will be very helpful if you do it today. Don't wait another 2-3 weeks, because the classes get filled very fast. And if you wait and the class is already filled, all you can do is just contact the instructor and ask. I usually add students if I have a class, but even if it's closed. But some instructors, they don't want to do it because lots of work. It's a lot of work to have extra students, and if you also give them chance to retake the test, it's again more. Well, I'm fine. I can do more. I love grading. Okay, but anyways, I guess we're gonna stop at this stage, and we're gonna continue next time. So thank you for being patient with this. I hope you start to redo this same problems like exercise number 69. I think it's a very good exercise, and you can just get a piece of paper. As usual, you will utilize it for your next package of homework, right? Okay, so I'm gonna stop recording. If no questions, I'll let you go and have a good day.
Thank you, Professor.